Hello everyone, welcome to our next topic on regression modeling, estimation, evaluation, and stepwise regression. This presentation will guide you through the powerful techniques of the regression modeling. We will cover estimation, evaluation, stepwise regression approaches, demonstrating these methods in both R and Python. By the end, you will have a deep understanding of how to build, refine, interpret, and robust regression model to uncover insights from your data. Introduction to Regression Analysis. What is regression? Regression analysis is a powerful statistical technique used to model and understand the relationship between a dependent variable and one or more independent variables. It allows us to quantify the strength and direction of these relationships, making it a fundamental tool for data-driven decision. Key application. Regression modeling has a wide range of application from predicting sales figures and housing prices to understand the factors that influence customer churn and employee attraction. It's an essential technique for researchers, analysts, and decision makers across many industries. Estimating regression models in R Python. First process is data preparation. In data preparation, properly cleaning and formatting your data is a critical first step before estimating regression. This includes handling missing values, encoding categorical variable, and ensuring your data is the right format for analysis. Model selection. Depending on the structure of your data, the research question. You may choose from a variety of regression model types such as linear, logistic, or polynomial regression. Each model has its own assumptions and requirements. Third point is model fitting. Once your data is prepared, you can use libraries like scikit-learn in Python or lm function in R to fit your chosen regression model to the data. This will provide you with esteemed coefficient and other model parameters. Evaluating regression model fit. R squared. In R squared, the coefficient of determination or R squared is key metric or evaluating how well a regression model fits the data. It represents the portion of the variance in the depending variable that is explained by the independent variable in the model. Statistical significance to determine if the relationship identified by the model are statistically significant, we can examine the p-values associated with each independent variable. Low p-values, typically less than 0.5, indicate that the variable has a meaningful impact on the dependent variable. Model diagnostics. Regression models rely on certain assumptions such as linearity, normality, homoscedasticity. Fourth point, residual analysis. Analyzing the residuals or differences between the observed and predicted values can provide valuable insight into model's performance. Patterns in residuals may indicate area for model improvement or the need of additional variables. Here is the code snippet. Example for a linear regression on a housing dataset using Python. The first step is to import necessary libraries such as NumPy, Pandas. Second step is to generate synthetic data for demonstration such random.seed example. Split the data into training test and training sets. Train the linear regression model. Make predictions. Evaluate the model. Plot the results. Now, linear regression on a built-in dataset using R. Load the necessary libraries. View the first few rows of the dataset using head. Fit a linear regression model. Summary of the model. Predict values using the model. Evaluate the model means R square or mean square error. Plot the results. Now we talk about the assumptions of regression models. The first is the linearity. The relationship between independent and dependent variables should be linear. Non-linear relationship may require transformation or the use of polynomials. Normality. The residuals or the difference between the observed and the predicted values should be normally distributed. Violations of the assumptions may impact the validity of a statistical inference. Homoscedasticity. The variance of the residuals should be constant across all the levels of the independent variables. Fourth is independence. The residuals should be independent of one another. Violations of these assumptions, such as autocorrection in same time series data, may require specialized modeling techniques. Stepwise regression approach: the forward selection, backward elimination, and bidirectional stepwise. In forward selection, this approach starts with the empty model and iteratively adds the most significant variable at each step. In backward elimination, we start with the full model containing the variable and then iteratively remove the less significant variable at each step, continuing until removing additional variable significantly decrease the model lift. Bidirectional stepwise. This hybrid approach combines forward selection and backward elimination, allowing both addition and removal of variables at each step to find the optimum model. Practical applications in Insight. First is prediction modeling, second is causal inference, and third one is model optimization.